We have a polar region here. This is the polar region, and we want to find the area of this polar region. And this region is generated by the graph r equal to 3 sine theta plus 5 for theta from pi over 6 to pi over 2. So this is pi over 6. So the angle from here to here is pi over 6. And then this is pi over 2. So we go from the x-axis, or the polar axis right here, all the way to over here, and that's an angle pi over 2. And we want to know what is the area of this polar region right here. And to find the area of this polar region, what we do is we fill them up with sectors. So here we fill them up with 4 sectors, and then we'll find each one of these wedge, in the shape of a wedge. We call it a sector. And so here we fill the polar region up with 4 sectors. And so what we do is we find the area of each sector and then add them up, and that will give us an approximate area for the polar region. And so this is 4 sectors, and then eventually what we can do is we're going to fill them up with hundreds and thousands of sectors. And when we do that, then we'll get the exact area for the polar region. And so again, these are the 4 sectors right here. And so now we're going to find the area of each sector. And this is sector number 1. And this angle right here, the angle from here to here, that's called the central angle for the first sector. Remember that this is pi over 6, and this is pi over 2. And so the angle from here to here is pi over 6. And then since we're going from pi over 6 to pi over 2, and then the central angle, since we divide it into 4 sectors, and then each central angle will be pi over 2 minus pi over 6 dividing by 4, which is pi over 12. And so the first central angle will be pi over 12. This central angle will be pi over 12. And then this will be pi over 12, and this will be pi over 12. And so each central angle is pi over 12. And then the angle from the polar axis, or from the x-axis to this line right here, is pi over 6. So this angle is pi over 6. And then this line right here, or this line, this is pi over 6, and this is pi over 12. And if we do pi over 6 plus pi over 12, then we get pi over 4. And so the angle from the x-axis to this line, so from here to here, be pi over 4. And to get the radius for the first sector, because to get the area of a sector is 1/2 times the central angle times the square of the radius. For the first sector, we know that the central angle is just pi over 12. But to get the radius, so the radius of the first sector, it depends on either the angle pi over 6 or the angle pi over 4. And so we can use either one. And so in this case, we choose to use pi over 4. But eventually, we fill this up with thousands of sectors, and then this angle here and this angle here will be about the same. If the central angle is very, very small, and then this angle versus this angle, they'd be about the same. And so it really doesn't matter if we use pi over 6 or pi over 4 to calculate the radius for the first sector. And for this polar region, the function was r equal to 3 sine of theta plus 5. And so to calculate the radius representing the first polar sector, we just used the pi over 4. And once again, the pi over 4 is this pi over 6 plus the central angle, which is pi over 12. And pi over 6 plus pi over 12 is pi over 4. And so we do 3 times sine of pi over 4 plus 5, then it's about 7.12. And so the radius for the first sector would be 7.12. And then to get the area for this first sector right here is 1/2 times the central angle times the radius squared. So it'd be 1/2 times pi over 12 times 7.12. And that will give us about 6.63. So the area of this first sector is 6.63. And this is the sector number 2. And again, this central angle for sector number 2 is also pi over 12. Each central angle is pi over 12. The angle from here to here is pi over 6. From here to here is pi over 12. From here to here is pi over 12. And so we go from the x-axis, or from the polar axis, all the way to over here. Then it's going to be pi over 6 plus pi over 12 plus pi over 12. And that will give us pi over 3. So it'll be pi over 6 plus 2 times pi over 12. And altogether that would be pi over 3. And so again, this central angle is pi over 12. And to calculate the radius for this polar, for this sector, for sector number 2, then we can use the angle from here to here, or the angle from here to here. And so we choose to use the angle from here to here, which is pi over 3. And so the radius for sector number 2 would be 3 sine of pi over 3 plus 5, which is about 7.59. And the area, once again, is 1/2 times the central angle times the square of the radius. And the central angle is pi over 12, and the radius is 7.59. And this will give us 7.55. So area for sector number 2 is 7.55. This is sector number 3. This central angle corresponding to sector number 3 is pi over 12. Once again, if we go from here to here, that's an angle of pi over 6, and then to here, that'd be plus pi over 12, and then if we go to here, that'd be plus another pi over 12, and then if we go one more time, it'd be plus another pi over 12. And so the angle from here to all the way over to this line, it'd be pi over 6 plus 3 pi over 12, or 5 pi over 12. To calculate the radius representing this sector number 3, then we can use the angle from here to this line, which is pi plus 2 pi over 12. Or we can use the angle from here to here, which is pi over 6 plus 3 pi over 12. And again, to calculate the radius, we can use either one. But here we choose to use the pi over 6 plus 3 pi over 12. And that's 5 pi over 12. And so the radius for the third, sector number 3, is 3 sine of 5 pi over 12 plus 5, which is 7.89. And so the area, once again, is 1/2 times the central angle and times the square of the radius. So it would be 1/2 times pi over 12, and then times 7.89 squared. And the area would be about 8.16. And so area for the sector number 3 is about 8.16. And this is sector number 4. Once again, for sector number 4, the central angle is also pi over 12. And to calculate the radius, we can use the angle from the x-axis, or from the polar axis, to this line. This angle right here. or we can use the this angle from the polar axis, or the x-axis right here, all the way up to over to the y-axis. And so the angle from here to here, it'd be pi over 6 plus pi over 12 plus pi over 12 plus pi over 12, which is pi over 6 plus 3 pi over 12. But if we go all the way from here to here, it's going to be pi over 2. Yeah, that's 90 degrees, or 4 pi over 2. And so to calculate the radius for the sector number 4, we choose to use the angle from here to over here, which is pi over 6 plus 4 pi over 12, or pi over 2. And again, we know that we go from here to here, that's an angle of 90 degrees, or pi over 2. And so the radius would be 3 sine of pi over 2 plus 5. And sine of pi over 2 is 1, and so we get 8. And area of the sector number 4 is 1/2 times the central angle times the radius squared. And that comes out to be about 8.37. And so now that we have found the area of each sector, and now we would add them up. And if we add the areas of the sectors up, then that will give us an approximate area for the polar region. And so here we add them up. This is area for sector 1, this is area of sector 2, and this is area of sector 3 and sector 4. And the sum is about 30.73. And so the area for this polar region right here is approximately 30.73. And now let's get a general formula for finding area of a polar region. Area of sector number 1, it was 1/2 times the central angle times the square of the radius. This is area for sector number 2. This is area for sector number 3. This is area for sector number 4. In using summation notation, then we would have I going from 1 to 4 for the 4 sectors, and then 1/2. This is the ith central angle, and this is the ith radius of the ith sector. And then just rewriting it a little bit, and then just move the delta, theta, psi to the end. And again, this is the, if we want the exact area of the sector, then instead of 4 sectors, we would fill it up with many, many sectors. And this is filling the polar region up with 100 sectors. This is 105, 110. And now let's fill it up with 1,000 sectors. And this is filling it up with 1,000 sectors. And we can see that if we add the areas of the 1,000 sectors up, that will give us the answer of 29.41, or the sum of the areas of the sectors. And so we can see that to get the exact area, then we can define it as this. Let the number of sectors go to infinity, or n runs to infinity. And so instead of 4 sectors, now we have an infinite number of sectors. And then in terms of the integral, then this will be the integral from alpha to beta. And so for this particular example, alpha would be pi over 6, and beta would be pi over 2. So alpha would be the angle from here to here, which is pi over 6. And then beta would be the angle from here to here, which is pi over 2. And so for the example that we, for this particular example, then we have alpha is pi over 6 and beta is pi over 2. And then r of theta, which is the radius, it'd be 3 sine of theta plus phi and then square. And then to find this definite integral, we can use numerical integration method like trapezoid's rule, and that will give us 29.41. And then we notice here that if we, this is filling the polar region up with the 1,000 sectors, and add the areas of those 1,000 sectors together is 29.4165. And here we get 29.41082. And again, the difference is this answer is we got this answer with by filling the polar region up with an infinite number of sectors. And this answer is just filling it up with 1,000 sectors. So that's the difference.